So let's talk about safety here for a second. Here, my home, right after hurricane, actually working on getting my system running again after restoring power, and I'm having an error code on my system where my compressor won't start. So let's talk about the safety of working on inverter systems. Now I know that they're complicated, and that what you can see here can be somewhat intimidating and confusing, but there's a safety aspect of this. So if we come here and we look, my meter's set to auto for the high voltage aspect, right? I have nothing. But what we should be checking here is actually our C plus and our C minus terminals. And you will actually find here C plus, C minus. I have 50 volts. Now this unit has been off for actually 10 minutes. And as you can see, my DC voltage is falling, but you know, about 45 seconds ago, I had 200 volts DC. And so why does that matter? As you can see, it's still falling. And as you can see here, I am connected here on C plus and C minus with my meter. Black negative on C minus, red on C plus. This matters because you have to remember that these giant banks right here, these capacitors on the side, they store voltage, right? For an inverter system to operate, we're not only just taking the AC voltage 240, 208 that we get here at the terminal, we're also converting it to DC voltage, charging these capacitors, and then allowing the board to use its IGBTs to simulate voltage, right? Simulate that AC voltage to run the compressor. This is important to notate because if you get in here on an inverter piece of equipment, you turn the power off to it, and you check your high voltage leads at your outdoor unit, you might think that you're safe and okay to start unplugging the compressor, start touching the inverter board, but you would actually be sadly mistaken, and unfortunately you'll get shocked. And it's a heck of a shock. Now this is only 208, 240, but you get into 460 volt equipment, you can easily get up to 1,000 volts DC stored on a capacitor charge. And so, you know, residential equipment, we always want to be safe around capacitors, but for inverter equipment especially, you're going to always want to check that C plus, C minus at the capacitors to ensure that they are below 50 volts, or my rule of thumb is usually 35. And as you can see now, I'm okay to work on this piece of equipment and troubleshoot it. So that's my safety tip of the day. All right, updates. So my system had an L5 error code. Turn that off. And wouldn't you know, the plug looked like it got a little toasty on that compressor there. A discoloration on the wire, all the wires melted together. But you see this inverter system, when it went to go start it, noticed that it was grounded out. Didn't even attempt to send voltage, so nothing is blown out. It looks like the quick disconnect plug is shot, so I'm going to do a repair on this and see if we can get it back up and running. So I've had a lot of people also ask me too, right, when you're cutting out these compressor plugs on this particular model here, because of, you know, this damage that you see here, it's important to notate that although they may be copper coming into here, coming out is not so much copper, right? That is aluminum wiring. We know that dissimilar metals, maybe not a good fit long term, so I am temporarily fixing this so that I can get this unit running. My wife wants air conditioning, and I will replace this with a factory plug. Remember, it's always important to go back with the OEM because it's there for a reason, right? But for right now, this is how we fix it. All right, connections are solid. As you can see, I've got crimp connectors here that are sized for the appropriate gauge wire, and as you can see, this wire, although it may be white, it did get a little toasty, but I assure you where I cut it back at is good. So let's hook it up and let's give her a test run. So while I'm here, let's not skip any steps, right? So if we're diagnosing a burned out plug, let's make sure that we also check our resistance on our compressor, right? Not only checking it to ground, but from winding to winding. So it is important to not just go back and put things that have burned out back together and hope that when I apply voltage to it, it's not going to blow out or cause damage to the system. And so remember, it's our job as technicians to be thorough and diligent, and not just because I'm getting rained on right now or because there is still a decent amount of wind trying to blow this panel off the top of the unit while I'm checking it. It's more important to make sure that when I turn this back on, I have the confidence to know that I'm not just going to blow out a winding or a terminal, or, you know, Lord forbid I blow out my inverter board, because I wanted to rush this process. And so, well, good news, I don't have a grounded compressor, OL in all 3 windings, and the windings are balanced. So I am now confident to hook this compressor terminal cable back up, and yeah, now I'm ready to test it. Okay, she is powered up and live. Let's go ahead and take some readings. Make sure that your hands are dry. Nobody wants wet hands when they're checking capacitors. As you can see, again, C plus C minus, and I'm only at 9.6 volts. This means that my system right now is actually looking to communicate with my indoor units, that it's not worried about charging of capacitors or fan motors. But you'll find that once it clicks, you'll hear a relay click, and then it'll start charging those capacitors. Once it charges those capacitors to the correct rated voltage, typically for this piece of equipment is about 300 volts, then you'll see the fans will kick on and compressor will start. So we'll keep you stay tuned. And there you have it. The fans are running, compressor is churning.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.